Hello learners, welcome to my class. In this session, we will discuss about the basic of polynomial, which learners must possess. Right? Today, we discuss relationship between zeros and coefficient of a quadrilateral. Right? Here, I have written quadratic polynomial, that is ax square bx c. That means ax square plus bx plus c, where a is not equal to 0. Now let's start, right? Let alpha and beta be the zeros of a quadratic polynomial, that is gx equal to ax square bx plus c. Again I am repeating, gx equal to ax square plus bx plus c, where a equal to 0. Then x minus alpha and x minus beta in bracket are the factors of gx by factor theorem, which we have learned in class 9. Gx equal to, we can write k x minus alpha in bracket and x minus beta in bracket, that is product, where k is a constant or non-zero constant, right? Again we have laid gx equal to ax square plus bx plus c, that you can write in the left hand side ax square plus bx plus c equal to k, where in large bracket we have already by split it with the help of distributive proof. Then we get this one, k big bracket star x square minus alpha plus beta in bracket and x plus alpha into beta, right? Again, next x step, we will take out the all from the bracket, right? We get in the right hand side kx square minus k alpha plus beta in bracket and x plus k into alpha into beta. On comparing coefficients of x square, comma x and constant on both sides, right? That means in the place of a, it is k. In the place of b, it is minus k alpha plus beta in bracket. In constant place, it is k into alpha into. Take it as an equation 1. Now, b equal to minus k alpha plus beta in bracket implies that alpha plus beta equal to b by minus a equal to minus b by a, because on comparing we get k equal to a. That means from equation. Therefore, alpha plus beta equal to b by a. That means sum of zeros, related zeros, alpha and beta, right? So, the coefficient of x, and it's also contain minus. So, I have taken here minus 1. In denominator, coefficient of x squared, that is a. We have compared it. Also, we can take a constant equal to k into alpha into beta. Transpose the k in the right hand side, it becomes in division as a denominator. Then now let's see. Alpha into beta equal to c by k equal to c by a from equation 1, right? So product of zeros equal to constant term by constant coefficient of x squared. Again, constant term over coefficient of x squared, right? Okay. Now, thus, remarks. If alpha and beta are the zeros of if alpha and beta are the zeros of the quadratic polynomial, then the sum of alpha and beta zeros equal to always minus b by a, and the product always alpha into beta equal to c by a. Product of zeros always c by a, and sum of the zeros always minus b by a. In remark 2, a quadratic polynomial whose zeros are alpha and beta is given by gx equal to x minus alpha into x minus beta into k, where k is constant. After computing it, we get this one, right? K, that after applying the distributive property, you get this one. So k in the over bracket, large bracket, x square minus sum of the zeros into indeterminate x, right? Plus product of zeros, right? For instance, we can take an example. Find the zeros of quadratic polynomial such as px equal to 6x squared minus 3, and verify the relationship between the zeros and the coefficient, right? In solution, we can write, or we write, given px equal to that, and it's we convert into root 6x squared whole, because root 6 into root 6, we write 6, right? 3 also it can be converted as like. After that, we know that the identity that is a square minus b square equal to a plus b and a minus b. This is in the form of this one, right? So we know that the zero of px are given by px equal to 0. Now px equal to 0 equal to, you can write that like this. So in the, you have to put a slash. Then in the left hand side, you can write root 6x plus 3 equal to 0. In the right hand side, we can write root 6x minus root 3 equal to 0. After computing, we get x equal to minus 1 by root 2 and or 1 by minus 1 by root 2, or we can write minus 1 by root 2 or 1 by root 2 plus. Hence, the zeros of px equal to 6x square minus 3r, alpha equal to minus 1 by 2, and beta equal to 1 by root 2. Sir, here you have taken 1 by 2. Why? It also 1 by root 2, no? So, we can write here alpha equal to 1 by root 2. Sum of the 0, it becomes 0. And coefficient of x equal to 0 minus coefficient of x square by 6, always it gets 0. So sum of the 0 equal to coefficient of x minus coefficient of x square. It's verified. Sum of the 0 equal to that minus coefficient of x over coefficient of x square. It is verified. Now let's start to verify the product of 0. After putting the value of alpha and beta, we get here 1 by 2 minus 1 by 2, right? And when you have take constant term over coefficient of x square, we also have minus 3 by 6. After cancelling, it becomes minus 1 by 2. So product of 0 equal to constant term over coefficient of x square, right? I hope that my learners understand this one. And this figure indicating, first of all, you see the question and become tensor. Then gradually you apply the concept and ground rules. Then you come to the yellow. After that, completing this one, you become happy. That means your mind is also become green. So for this today's session, I hope that all of you understand, and thank you all of you, my learners.